All right, we're going to talk about an arithmetic sequence. I've got 3 arithmetic sequences up here. An arithmetic sequence, if you'll notice in this first sequence, it's just a sequence of numbers that has a particular kind of pattern. To get from one number to the next, I'm adding 3 each time. And so in this sequence, the next number then would be gotten by adding 3, so 19 plus 3 is 22. That would be the next number in that particular sequence. This is an arithmetic sequence as well, where we are also adding 3 each time to get the next number. Now, notice that this sequence of numbers never shows up in this sequence of numbers. Like I said, 19 plus 3 is 22. 22 does not show up here. So they're both obtained the same way, but they're not the same sequence of numbers. What's the difference? Well, the difference is in the first term. So the first term of an arithmetic sequence is pretty important. All right, here's an arithmetic sequence that is found by subtracting 2 each time. So an arithmetic sequence is built on adding or subtracting the same number each time. Here we're adding plus 3. Here we're adding plus 3. Here we are subtracting minus 2. Okay, well, this plus 3, this minus 2, is called our common difference. We use the letter D to represent this common difference, all right? So for this sequence, D would be 3. For this sequence, D would be 3. For this sequence, D would be negative 2. So let's talk about the nth term of an arithmetic sequence. So the nth term is found by starting with the first term. Remember we said this pattern of numbers depends on where we start. So we start with the first term, and then we're going to add this common difference so many times. Well, how many times are we going to add it to find the nth term? Well, let's look at this first sequence for an example. So here's my first term, it's negative 5. If I want to get to 7, 7 is the 5th term. 1, 2, 3, 4, 5. 7 is the 5th term. And look, I add D, I add plus 3, 1, 2, 3, 4 times. So we're going to add to our first term, we're going to add the common difference D, n minus 1 times. And this is the pattern for the nth term in an arithmetic sequence. So if we wanted to find, for example, a 100, then I start with my first term, which is negative 5. I add my 3, and I do it 100 minus 1, or 99 times. So we've got negative 5 plus 3 times 99. Now, that's negative 5 plus 3 times 99 is 297. So 297 minus 5 is 292, and this would be my 100th term. That's what that means. Okay, well, let's suppose that we have a different sequence that's not on the board. Let's suppose that I know something about another arithmetic sequence. Let's suppose that I know that A sub 40, that the 40th term is 168, and that the 60th term is 248. All right, well, let's see if we can come up with an nth term pattern for this sequence. Well, I know that between 40 and 60, okay, from 40 to 60, there's 20 numbers. All right, I'm going to have to add D 20 times, in other words. To get from 40 to 60, I'm going to have to add D 20 times. Well, so there are 20 D's between here and here. Well, let's just see how far that is. 248 minus 168. All right, this is 0. 14 minus 6 is 8. So I'm going to have to add D. I'm going to have to add 20 D's to get that 80 difference. So 20 D's gives me the difference between these two numbers, gives me 80. Just like 4 D's gave me the difference between 7 and negative 5. 4 times 3 is 12. I had to add 12 to negative 5 to get all the way up to 7. Well, here I've got to add 20 of my d's to get to 80. Well, then that means d must equal 4. So I found d. All right. Well, let's just use one of these numbers then to figure out what the first term is. So we'll do A4 equals 168. So 168 then is equal to my first term plus my 4, my d, and then this is the 40th term. So n is 40, and then I subtract 1. So I've got 168 equals a sub 1 plus 4 times 39. All right. Well, 4 times 39, so a sub 1 plus 4 times 39 is 156. So now if I take 156 and subtract it from 168, then I get 12. So a sub 1 must be equal to 12. So I know a sub 1, I know d. Now I can write my a sub n pattern for this particular sequence. And a sub n would equal 12 plus 4 times n minus 1. Okay, so now we know what the d is, that it's the common difference, and we have a pattern for our nth term in the sequence. So let's talk about the sum of a series of these numbers. All right? If I wanted to get the sum of a series of these numbers, how would that work? Well, let's say, in other words, that I want the sum of the first 10 terms. That's what S10 means. Well, look at our first sequence of numbers right here. You know, the sum of the first 10 terms, well, I could write them all out and add them up, okay? But really, I just want the first 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. I would need to put 22 in there, and then I'm going to add all of those up. But the formula for the nth sum, the sum of the first n terms, is the number of terms divided by 2 times the first term plus the nth term. So in order to find S sub 10, then I have 10 terms, 10 divided by 2. I know my first term is negative 5. I would need to find the 10th term. All right, so I'd have to know this to find my 10th term. Now, we already said the 10th term here is 22. All right, so I can just put that in, and I can say S sub 10 equals 5 times negative 5 plus 22. So that's 5 times, now 22 minus 5 is 17, and then this is going to be 85. So the sum of the first 10 terms in this first arithmetic sequence is 85. Another way to write the sum would be using our sum symbol here. And with this sum symbol, n goes from 1 to 10. So this is your first number that n gets to be. This is the last number n gets to be. And you would put your formula for a sub n right here. So we never wrote the a sub n for that first pattern. Or yes, we did. We had it on there earlier. A sub n, remember, was negative 5, which is my first term, plus 3, which was my common difference, times n minus 1. So to write the sum using this sum symbol then, we would, I'll angle this down just a little bit, we would say the sum as n equals 1 to 10 of, and I'm going to put in parentheses, negative 5 plus 3 times n minus 1. This is how you would write the sum of the first 10 terms of that first sequence using the sum notation right here. Okay, now what if you had the sum symbol n equals 5, let's say to 15, of some a sub n pattern? What if you had that and you had to figure that out? Well, in this sum formula right here, a sub 5 would be your first term. So your first term would be a sub 5. That would be your first term. And then your last term would be a sub 15. Now, how many terms would you be talking about? What would n be? Well, 15 minus 5 is 10. But don't forget that you also have to include this term. So there are actually 11 terms. Just like right here, 10 minus 1 is 9, but we have to include the first term, 10. So there are 10 terms right here, represented right here. 10 terms in my arithmetic sequence. There are 11 terms in my arithmetic sequence right here. You subtract these two, and then you add 1 to count in that first term.